Okay, so hello everyone. In this video, we'll be solving the question number 1140, which is the Stone Game 2. It is marked medium. Question is very easy to understand. Constraints are very small. First, we'll understand the question, then understand an example with the help of a diagram. Later, we will form an approach and do the implementation. If required, we will do the optimization part as well. So let's first understand the question and then we will move to the examples. Okay, so what does the question want to say is that Alice and Bob continue their games with the piles of stones. There are a number of piles arranged in a row, which means that it is an array. And each pile has a positive integer number of stones, which is piles of I. Each which means that at ith index of piles array, there is an array which contains positive number of stones. That means the ith pile has some positive number of stones which is represented by piles of I. The objective of the game is to end with the most stones. That is, whoever is playing the game, everybody wants to accumulate the most number of stones. Okay. Alice and Bob take turns, with Alice starting first. This is one of the main thing is that Alice is the one who will start the game. She will be making the first move. Okay. On each player's turn, that player can take all the stones in the first X remaining piles. This is the most important thing, where X is in the range from 1 till 2 into M. Okay, so let's first understand what it wants to say. Okay, so suppose this is one of the array, which is the piles array, and M is 2. So X can be in the range of 1 till 2 into M, which is nothing but 2 into 2, which is 4. So we can take first 4. It is till A, B, C, D. So it is upon us that whether we want to just take A, or we want to take AB, or we want to take ABC, or we want to take all fours. Okay. So that's what it is said here. And we set m equals to max of m or x. So whatever we pick, suppose we pick 2, so the m will be the maximum of the current value of m, and x which was the number of elements or the stones that we have picked, and initially m equals to 1. Okay. The game continues until all the stones have been taken. Suppose all stones are exhausted or are chosen or are picked, the game ends at that point. Assuming Alice and Bob play optimally, we need to return the maximum number of stones Alice can get. So, what does it mean is that both the players play in the best way possible so that they can maximize their score from the available piles of stones. So, whatever resources they have, they will try their maximum. They will try to get the maximum score by playing efficiently, most optimally. Okay, and what you need to do is return the maximum number of stones Alice can get. Okay, so now let's move to one of the examples. Suppose a pile array. Suppose the piles array has this elements, which is 2794, and initially we know that m equals to 1. Alice starts the game. Okay, and x can be from 1 till 2 into m. Okay, so initially m is 1. M is 1, where it is here we have m is 1, and it is Alice's turn. Okay, so she has two options. Either she can take 1, either she can take 1. Let's take a better color. Either she can pick 1 or she can pick 2. Why is that case? Because 2 star m, which is 2 into 2, which is equals to, sorry, 2 into 1, which is equals to 2. So x can be in the range of 2. So we can take one element or two element, or two piles. Okay, so suppose he takes the first, Alice takes the first pile. So these two is chosen. These two is chosen. So only four elements remain. Four piles remain, which is this 7, 9, 4, 4. If she decides to take two piles, which is 2, 7, then these three piles remain, which is 9, 4, 4. Okay. So if she takes the first pile, her score will be 2. If she takes the rest first two piles, her score will be 9. Okay. Now it's Bob's turn. Bob has four choice, and here he has three choice. But before that, what we need to do is we need to update m, which is nothing but max of m comma x. Okay. So in this case, x was 1, m was also 1, so it is max of 1 comma 1, max of 1 comma 1 1, and in this case x was 2 and m was 1, so it will be max of 1 comma 2. So here m is 1 and m is 2. So once again, so what is the possible range? Which is 1 till 2 into m. Here m is 1, so 2 into 1 will be 2, and here it will be 1 till 2 into 2, 2 into m, which is 2 into 2, which is 4. So here also Bob has four options. It is like 1 pile, 2 pile, 3 pile, but fourth pile is not available, so he will go till 3 pile, and here he can take two piles, two options, which is 1 pile or 2 pile. So he will take 2 piles, which is 7 and 9. So his score will be 9 plus 7 and 16, which is 9 plus 7 and 16. In this case, if he tries to play optimally, he will take all three piles, which is 9, 4, and 4. So here his score will be 17. So now, since in this case all the piles are chosen, so Alice has no options. So Alice score will be 9 if he chose this path. If she chose this path. Now this path is still left. If Bob plays optimally, he will take two piles, 7 and 9, and Bob's score will be 16, which is 4 and 4, and m is maximum of 1 comma 2. Here also 2. So what we will do is Alice will take two piles once again, which is 4 and 4. Now she will get 8 more score. So her score will be increased by 8. So originally her score was 2 and plus 8. So what she will do is she will choose this part, because here her score will be 10, and by choosing this path her score will be 9. So maximum score Alice could get is 10. Okay. So now how we should move to get the maximum score? In the previous parts we have decided that we will not go like calculating the score, but rather calculate the difference. Okay. So what we had decided last time was that what we decided last time in the previous part is that instead of calculating score we will calculate difference. So to play optimally, what each player will try to do is maximize the difference. Okay. So if they will optimize the difference, they will get the maximum score. Okay. They will also want that the other player gets the least possible score, so that I can get the maximum score. But the other player will also think that okay, I'll get the maximum score so that the difference could be reduced. So we'll start with Alice. Her score is A. Okay, sorry. Suppose her score is A after playing this move. Here it is 2 and here it is 9. Now suppose after playing this move, her score is A 1 after this move. And so she will think that okay, after whatever remains, whatever be the Bob's score. Suppose let the Bob's score be B. So A1 minus B be optimized or be maximized so that she could get the maximum available or play optimally. Now it is Bob's time. Bob's score. So suppose Bob's score at this move be B1, and he will think that okay, whatever follows, whatever be the score of Alice after this be A. So he will try that okay, let this be maximized so that whatever is passed over here can be used to overcome this. So Bob can get the maximum score. So what everyone is trying is to maximize their difference. So suppose A be the Alice score and B be the Bob's score. So we found that A minus B is X. By, sorry. A minus B equal to Y after they play optimally. And we also know that A plus B equals to sum of all the stones in all the piles. So if we get this and if we get this, we can simply find the Alice score. How? Suppose suppose A minus B equals to D and A plus B equals to S. So we can say that A is nothing but S plus D by 2. How we can say that A equals to S plus D by 2? Using this, using these two formula, we can just simply add them. So these two will get cancelled. So it will become 2, 2 star A equals to D plus S. Okay. So A is nothing but, from that we will get that A is nothing but this. Okay. From this we got this. And from this we got this. Okay. So what we are doing is we calculate difference, we maximize it, and then we will find A. Okay, so how will we find difference is that suppose it is Alice's turn. Suppose it is Alice's turn, we know that we have the value of M. So we know that the value of range of X. So we will iterate from 1. We will iterate that value, that range. And what we will do is we will pick that element. What we will pick that element and pass. We will pick that element and give the rest to next guy. After we have chosen, suppose let's move this first here. Suppose we choose this two, the remaining will be this much. So after choosing, we will send the remaining elements to the next guy. After suppose Bob chose 9, we will send this remaining, which is 4 4 to Alice. Okay. So we send the remaining. We pick, first of all, we pick whatever is in the range, and then send the remaining to the next guy, and let her be okay. Now you play optimally. I have chosen the optimal. I'll select whatever will be the best score me for me. So you play optimally, and I'll arrange my picks as per your picks. Okay. So let's implement it. Will require a helper function, because you can see that from each possibility there are so many possibilities. You can think that this is a recursion happening. So we will create a helper function. As of now we don't know what we need. We know that okay, I need integer I and I need integer m to find the range, and I need the vector files, which is the main thing from which we will get the number of stones. And we are given that the game continues until the stones have been taken. So if all stones are exhausted, If all stones are exhausted, that is I has reached the end, or it has crossed the, what you can say, the limit, which is piles dot size. We will return 0. Okay, now I have nothing. I have nothing to offer to you. Okay, now we will find x. Find x, which is int. Sorry, we will find range. Okay, so let int range equals to 2 star m. Okay, and we will iterate the range. Okay, for int I equals to 1, I less than equals to range, and I plus plus. Okay. Okay, so to reduce ambiguity with this I, we will rename this I to j, but we also need to make sure that the I, which is, if we are, in this case only, if we are at this I and we can take 4 piles, but we know that there is no fourth pile, so we'll stop at 3. So we need to make sure that I plus j, just a second. So we need to make sure that I plus j less than equals to piles dot size, and j less than equals to range. Okay, so I plus j doesn't go beyond the pile's size, and j is also very well within the range. Now suppose we take that. Suppose let's initialize that sum equals to 0. Our pick till date sum. Okay, let us pick this, which is nothing but sum plus equals to piles of, what it will be, uh, hmm, it will be j plus I. Okay, and we will send the rest remaining to the next guy, but we will also need to check that what is our peak value, and we want to maximize it, so we will declare it with int min. Okay, so okay, our peak value will be the max of peak value, and what is our sum till date, and the difference with the whatever other guy is picking. What he is picking, helper. Now his new j will be j plus I. Okay, so his remaining array will start from j plus I, and the value of m will be maximum of max comma I. Yep, j, which is this range, and here it will be j plus I minus 1. After we have done that, we need to pass the files head. Okay, now what we will do is we'll return peak value. Peak value is nothing but the difference. So what we have done is we will accumulate the sum of our peaks till a particular index. So that's why we have done it with 0, and after each peak we will add it, so which is with j plus I minus 1, and the remaining will be sent for the other player's turn, which will be, so next index will be j plus I, and max will be updated, which is the current m, and whatever will be the peak, which is value of x in the range, the number of elements that we are picking. Okay, and we will maximize it, and we will return the peak value. So let's just call this, and since we are returning integer, here it will be okay, so let's first initiate m with 1, and we will. Okay, now we need the sum as well, because we will be using sum and difference to calculate Alice score. So now we will iterate each value of piles and add it, and we will return the value, which is s plus d by 2. Okay, why we are initiating this particular variable? Because we are doing max over here and passing that where we are doing max. So we need a variable over here because directly using it will won't work. So that's why we will be using variable. So let's first check, is this compiling properly or not. Okay, compilation error, which is sum. Okay, sum, and here it will be diff. Okay. This is giving TLE because you can see that at each point there is branching. More possibilities are created. There is a tree. So there are creating more and more and more possibilities. So it is getting exponential. And there are 100 possible values of M. So it is getting like, for it is not 2 power M or 3 power M or 4 power M. It depends on the value of M and X. So it is unpredictable. So now we will memorize it. So how we will do is we will create a DP. We will start with DP. So let's first understand that how what variables are changing. I is changing and M is changing. So I is in the range of 1 till 100. So we will need 101 states because till 1 till 100. Okay. Now for M. Suppose we take the biggest values of M and pick that number of piles. Suppose if M equals to 1, we can take 2 and then 98 piles remain. Later, if M equals to 2, we can take 4 piles. So you can say that 94 are remaining. If we take M equals to 4, then we can take 8. So we can say that 86 are remaining. So by the time M becomes 100, everything will be exhausted. So that is also we can take M from 1 till 100. So we will need 101 step. Okay. And we will pass it in the functions. And we will use it everywhere. And we will check if this is like pre-calculated or not. V of I of M, which is not equal to -1, we will return that. And we will also update its value over here. And we will call that over here as well. Let's first check whether it is compiling. Okay. Okay, so it is compiled. Now we will see the time complexity. Time complexity, first of all, is on the number of variables changing. Here I and M are changing, so it will be n square. N square is what you can say fixed, but we have a for loop here inside as well, which is till range, which is 2 power m. Suppose 2 power m becomes equal to the length of the array, it will be n. So n square is already there, and there is one inner loop which can go till n. So it will be n power 3. So okay, and space complexity will be also n power 3 because 101 star 101, which is n into n, and the stack trace. Okay, so I hope you guys enjoyed it, understood, and if you have any doubts, do let me know. Comment section is